Alright guys, so today we're going to be covering Unit 9, Section A. These are our online lecture notes. This is the first one of the continued learning, so I got a couple things just to let you guys know beforehand. First off, the notes for today. We're going to be focusing on 9.1 is what we'd be covering in the classroom. Introducing areas, specifically today, triangles and parallelograms. So, every week you guys are going to have about 3 things that are going to be needing to be turned in. So assignments are all due by Sunday 11:59 p.m. So you guys have all week to do these. These assignments will be posted every Monday at 9 a.m. So you guys will have 2 homework assignments in there and then 1 assessment assignment in there. Further, I'm going to be making these video lectures for you guys. That way you guys have these for the notes, and then there's also online notes that you can also copy down. I have been finding some errors in the keys. The teachers that are making these keys are posting some errors with them as well, so I'll be making sure that these are all up to date. Of course, if there are any errors, if you catch any while I'm going through these, please make sure that you comment, let me know, and that way I can go ahead and fix those up. So, as you guys are going through these, if you get stuck, if you have any issues, I am going to have office hours every weekday, Monday through Friday from 11 a.m. to 1 p.m. So those will all be in Google Meet. So if you don't have Google Meet, I highly suggest that you download that app. I'll be posting up all the information in Schoology. So further info will be in Schoology. Make sure that you guys check that out. I will be there. If I'm not at my computer at the time, just yell my name, get my attention. I'll come over and help you guys out however I can. But I will be posting up in Google Meets every Monday through Friday from 11 to 1 for you guys. If you have any questions, make sure that you show up to those office hours. Again, we just went over those office hours. And then also, if you can, before you show up for office hours, send me an email about your problem and a picture of your work, preferably before office hours begin. That way I can kind of put it inside a presentation and actually go through the problem. I may be able to even make a video of it if I have time. So, getting started on today's notes. Today we're going to be talking about area. So, this is all about area. Most of Unit 9 will be covering area, and all this week is only area. So, what area is the amount of space that a 2-dimensional figure makes up. So, again, we're not going to be in 3D this time. It's just all 2 dimensions. Now, the area of a shape is measured in square units. So, when we were dealing with volume, we were in units cubed, because 3 dimensions. Now we're in 2 dimensions, so our units will be squared. So the unit can be any unit of length, such as square feet, square inches, and square meters. There are plenty more. Any distance to a power of 2, that would be the unit squared. So, here is a square inch. Imagine that each of these boxes are 1 square inch. So I have a box here. That means that each side is 1 inch. And it makes a square out of it. So our area would be 1 times 1, or 1 square inch here. Now I went ahead and wrote it in a couple different ways. 1 square inch, or 1 inch to the 2nd power. These are the same exact thing, so just make sure that you're knowing that they're the same thing. This was a meter instead of an inch. It'd be 1 square meter, and so on and so forth. So, first example. How many square inches are in the following shapes? So for this first one, the circle on the left. Now, we're not going to get an exact answer here because circles are very hard to get those exact answers unless we have our formulas. And if I need to, I can just go ahead and start counting these boxes. So I see that we have a 5 by 5 box here. And if I find the area of that, if I count up all these boxes, I end up getting 25 in the middle. Now I start going to the edges. So on this purple side over here, I see that we have 1, 2, 3. Now if I combine all these last pieces remaining, it's about 4. It's not perfectly 4, but we can say it's about 4. Same up top. If I count up all the boxes, we're at about 4 again. 1, 2, 3, and then these 2 combined equal about 4. And then for the green down below, 1, 2, 3, combine these 2, we get about 4 once again. And then for our yellow box, we have 1, 2, 3, and then if I combine all these, it looks like we almost have 5 here. So again, this isn't an exact science. These are all close to, they're approximately these measurements. So it's not the exact area. It needs to be very clear here. So the area of the circle, if I add all these up, 25 plus 5 plus 4 plus 4 plus 4 will be about 42 units squared. Now again, it's not going to be exact because we don't know for certain if these will make up a whole box or not. We're just kind of rounding here. However, if we're given a rectangle, we can actually find the exact area. And we do that by just counting up these boxes. So I have 3, 4, 5, 6, 9, 12, 15, 18, 21, 24. So we have 24 square units. Another way to do that is just length times width. 3 times 8 will give me 24. So here's a postulate for us. Two congruent shapes have the same area. That's always going to be the case, no matter what. If they're congruent shapes, they'll have the same area. But is the converse true? If two shapes have the same area, would they be congruent shapes? Well, go ahead and think about that for a second. And if you can prove it, fantastic. If there's one case where it's not true, then we know that's not true for all of them. So, I can think of one. If I have two rectangles here, one is 4 by 12, the other is 6 by 8. If we use the formula area is equal to base times height, then I get area is equal to 4 times 12, which is 48 units squared. And I get 6 times 8, which is also 48. And that is also units squared. These have the same area, but as we can see, they're not congruent. Sides don't match up. So therefore, these are not congruent shapes, and that means that the converse of our postulate is not true. All right, so moving on to familiar area formulas that we should already know. The first one is the triangle. So the area of a triangle is 1/2 base times height. The height is the altitude of the triangle. So again, altitude goes from one vertex down to the other side length and intersects at 90 degrees. On a right triangle, it's just one of our sides that's not the hypotenuse, one of the legs. In an obtuse triangle, our height is outside of our shape. Now, I can also make a height inside our shape if I'd like. This would be my height, and then this would become our base. However, in this case, we have our height right over here. It intersects at 90 degrees. So this would be the height of the triangle, and this would be the base. But multiple ways I can go through it. Again, I can go from any vertex to the opposite side as long as it intersects at 90 degrees, creating that altitude. Lastly, we have the acute triangle over here. Again, we have our height being an altitude. It goes from one end to the other and intersects at 90 degrees. And then our base is perpendicular to our height. So that's also very important to know. Our height and our base will always be perpendicular to each other. And that's how I know which side is the height, which side is the base. And again, just some important tips here. Knowing that each side can be a base, it just depends on what we're looking at. Again, I can make my height right over here, and then this would become base. So it depends on how you want to go through these many possible ways. Just know that height and base will always be perpendicular or intersect at 90 degrees for us. Next, a parallelogram, a rectangle, and a square. So, for these, the area is just base times height. So that won't change. In fact, if I were to cut out this triangle right over here, and I were to just translate it right over here, I'd have another triangle. Now, what would that make for us? Well, if these are 90 degrees because they're altitudes, that'd create a perfect rectangle. We know the area of a rectangle is base times height. So that's why that equation works with parallelograms as well. Now, very important that we know, this side length right over here, these sides that are next to, that are consecutive to the base, these are not our heights. Our height must always be an altitude, meaning that it goes from one vertex to the opposite side and intersects at 90 degrees. For a rectangle, well, we know that's just height times base, or length times width, however you want to go through that. And then for a square, since all sides are congruent in a square, area is just equal to one side of the square raised to the second power. Now you can still do height times base, and that'll still get you the same exact answer. They're equivalent in this case, because again, squares have all sides being congruent. So that saves us a little bit of time with those. All right. Next up, some examples. So with these examples, go ahead and pause at any time. Try them out on your own. If you're not sure, go ahead and watch me go through it. But the practice will come if you guys try these problems out. And it makes the assessments, makes the homeworks much easier. So go ahead and take a second, try this one out. I'll be going through it in just a minute. All right. So here is our answer. If we're looking at this, we see a right angle forming right in the center here. So this would be our altitude. And within triangles, I know that my altitude will be my height. It goes from one vertex to the opposite side, intersects at 90 degrees. So since we have a triangle, we're going to use the formula area is equal to 1/2 base times height. My base is 15. My height is 10. My height is 10. And I know that's the case because they're perpendicular to each other. So we have area is equal to 1/2 15 times 10. This gives us area is equal to 1/2 of 150 from 15 times 10. And then half of 150 is just 75. So area is equal to 75 centimeters squared. All right, hopefully that one wasn't too bad. Here's our next one. Go ahead and try this one out. I'll be going through it in just a second. All right, so looking at this, once again, we have a parallelogram this time. So we're going to use height and base to find the area of this shape. So no area is equal to base times height. Our base is 26, my bad. Our base is 26. Our height is 17. So 26 times 17 will give us 442 inches to the second power. All right, next, try this one out. All right, so this time we have an obtuse triangle. Our angle, one of our angles is larger than 90. So if I'm trying to find the height, well, the height's going to be outside and it's going to intersect at 90 degrees down here. So we have our base is 15, our height is 19. Area is equal to 1/2, 15 times 19, which will give us area is equal to 1/2 of 285. If I take half of 285, we're left with area is equal to 142.5 centimeters squared. All right, so hopefully these have been pretty basic so far, not too difficult. We're going to ramp up the difficulty now. So here's a very specific type of triangle that we've dealt with in the past, an equilateral triangle. Given an equilateral triangle with side length S. So looking at this, all of our side lengths are length S. See that down there, and then this is also S right over there. Now, in this case, our base is S. Our height is what we need to find. So if we're looking at this, and each angle is 60 degrees because it's equilateral, if I create an altitude, that's also bisecting our angle. So this would become a 30-degree angle, and now all of a sudden we have 60, 30, 90. So if we recall back to 30, 60, 90 triangles, the side opposite 30 is x, side opposite 60 is x rad 3, the side opposite 90 is 2x. Now in this case, very important for us, we know that our side length is s. So 2x, our hypotenuse, is actually equal to s. Well, if that's the case, then x is just 1/2 of s. Because I can say, oh, s is equal to 2x. Well, therefore, x is equal to 1/2 s. So in this case down here, we get 1/2 of s. And then that's my x value. So to find the side opposite 60, our height, our altitude, we do 1/2 of s times rad 3. Now, from here, we see that height is equal to 1/2 of s times rad 3. We can plug that into our area formula. That way we can find a formula that works for all equilateral triangles. So we have area is equal to 1/2 base, well, base is s, times height. Well, height we just found out is 1/2 s rad 3. If I multiply these out, 1/2 times 1/2 gives me 1/4. S times s gives me s squared, and then the rad 3 is just hanging out on the end here. So area of an equilateral triangle is equal to 1/4 s squared times radical 3. And that will always be the case. Now you may also see it written down here in a different way. This is the exact same thing. They just put it all underneath 4 instead. So they just move this 4 underneath everything. Works exactly the same. Whatever way you're more comfortable with, please feel free to do that way. All right. So with what we just learned, try and solve this one out on your own. Go ahead and take a minute, pause the video if you need to. I'll be going through it in just a second. All right. So looking at this, first off, we don't have a height. Now you get to choose which side length you want to create your altitude from. I'll go ahead and make it look just like the example that we were doing before. So I have this altitude here. This is my height. And I also know that these are 60-degree angles. So if I have 60 and 90, that means that our last side is 30 degrees up top. So again, we have a 30, 60, 90 triangle. The side opposite 30 is going to be 4, because again, this is going to create two congruent triangles here. So this side length would also be 4. Now, if x is 4, our height should be 4 radical 3. So from here, we can go ahead and find our area. Area is equal to 1/2 our base. Again, our base is the entire thing, 8, times our height, 4 radical 3. Well, if I do the math here, 1/2 of 8 is 4. 4 times 4 gives me 16, and then the radical 3 is just hanging out on the end. So area is equal to 16 rad 3 units squared. That's what the U stands for. U is for units. All right. Next, getting a little bit more difficult. Find the area of the figure. It's a parallelogram with side length 16 and a side length of 10. The other thing that we notice here is that we have a 60-degree angle right in one of the corners of our parallelogram. Is 10 the height? Well, if we think about it, 10 does not intersect 16 at a 90-degree angle. It's not an altitude. So therefore, no, 10 is not the height in this case. 10 is just a side length. So what we need to do is we need to find the actual height. So we're going to go ahead and create an altitude. This is our height. We have 60-degree angle, which is very useful for us. That means that this is 30 degrees. And if they gave us something other than 60, we can always use right triangle trig and solve for it if needed. So the side opposite, sorry about that. The side opposite 60 is x rad 3. The side opposite 90 is 2x. Side opposite 90 is 2x. And then the side opposite 30 would just be x. So in this case, if 10 is equal to 2x, that means that the side length over here, 5, is equal to x. Well, 5 is equal to x, then our height should be 5 times rad 3, or x rad 3, as we can see from our special right triangle, which will give us height is equal to 5 radical 3. From here, our base and our height intersect at 90 degrees. So area is equal to base times height, because it's a parallelogram. Our base is 16. Our height is 5 radical 3. So area is equal to 16 times 5 rad 3. If I multiply these out, we're left with area is equal to 80 rad 3 units squared. Again, this important note is key for understanding which side is your height and which side is your base. It all depends on perpendicular angles. So if you don't have perpendicular angles, they won't be base and height. One of them may still be your base, but that doesn't mean that the other number is your height. All right, getting a little bit more difficult here. Find the area of a figure. We have an obtuse triangle with side lengths 6 and 14 with an included angle of 30. So 6 and 14 for our side lengths. The angle included, the angle in between, is 30 degrees, which means that we must have a 60-degree angle up here if this is 90. So another 30, 60, 90 triangle. Well, the side opposite 30 is x. The side opposite 90 is 2x. The side opposite 60 is this whole thing, x radical 3. Now, luckily we don't need to do too much with this because it gives us a lot of information already. In this case, I see my 90-degree angle that's perpendicular to our number 6. So 6 would be our base here. So 6 is equal to base. Meanwhile, we need to find height. Well, height is x, and if I know that 2x is equal to 14, that means x is equal to 7. From here, we can use our area formula for a triangle. Area is equal to 1/2 base, which is 6. Oops, sorry about that. Base, which is 6. And height, which is 7. This will give me area is equal to 1/2 of 42. Area is equal to 21 units squared. You could have also done area is equal to 1/2 times 6, which is 3. 3 times 7, giving us 21. So either way works. Whichever way you want to multiply works perfectly fine. So we get 21 square units for the area of this obtuse triangle. All right, moving on. Find the area of the figure. So we want to find the altitude of a triangle with an area of 1,298.5 inches squared and a base measuring 53 inches long. So go ahead and try and draw this out for a second. See what you'd get. So I have my triangle here. I know that my altitude, or I want to find the altitude, so I want to find altitude. And I know that I have a base that's measuring 53. So if I'm finding this altitude here, my base needs to be perpendicular to it. So there's my base. I also know that my area, all this space, that is equal to 1,298.5 inches squared. Using our area formula, area is equal to 1/2 base, which is 53, times height, which is our altitude. You can go ahead and plug in 1,298.5 in for capital A, area. So we have 1,298.5 equals 1/2 of 53A. From here, if we solve it, 1/2 of 53 is 26.5. So I have 26.5 times A equals 1,298.5. If I want to get A isolated, I divide both sides by 26.5. And 1,298.5 divided by 26.5 will give us our final area of 49 units. Now this isn't units squared because, again, this is just a distance. This isn't my area here. I'm just finding the height. Now, maybe like Mr. Garner, this triangle looks different from this triangle. You're absolutely correct, it does. It doesn't matter which type of triangle you draw. These are arbitrary triangles. I could draw an obtuse triangle or a right triangle. It would not have mattered. It would have given me the same exact thing regardless. All right, let's continue on. Here's our last problem for the notes for today. We need to find the area of the shape below. Whoops. So, with this shape, my best advice is to start cutting it up. Now, there's two different ways to go about it. The first way is you can create a large triangle. create a not large triangle, a large rectangle, and subtract areas. My method is to break it down into multiple rectangles. If I break it down into multiple rectangles, I can just find the area of each of these rectangles. It's not very difficult to do. So I started over on the blue side. I notice that this side length is 6, and if this side length is 2, I know that opposite sides of a rectangle are congruent, so this side would also be 2. So 6 times 2 will give me 12. So that's where this blue comes in. Next, for my red triangle, or rectangle, I keep saying triangle. For my next red rectangle, I see that this side length is still 6 from the blue, and I see that this top here is 2. So 6 plus 2 gives me 8 for this side length. And meanwhile, down here, if this whole thing is 6, and this part is just 2, then 6 minus 2 will give me the side length of 4. So therefore, I get 4 times 8, which will give me 32. So 4 times 8 right here turns into 32. Ignore this B up here. This is just a mistake from earlier. Next, our green triangle. If this red side length is 4, and the entire thing is 5, well, 5 minus 4 will give me the side length of 1. And if this side length is 2, and this whole thing is 8, well, 2 plus 8 gives me 10. So I have 1 times 10, which will just give me 10. Lastly, for our purple, I see that this side length is 6. So this other side length must be 6 as well. The whole thing is 8. But I remember that I took out this little 1 over here for our green rectangle. 8 minus 1 will give me 7. So this side length, both these side lengths would be 7. So 6 times 7 will give me 42. That's where this comes in. Now our area is just combining all of them together. So 42 plus 10 plus 32 plus 12 will give us a final area of 96 units squared. All right. So this assignment that is covering for these notes, this is day 1, practice 9.1, area of triangles and quadrilaterals. Make sure that you guys attempt these on Schoology. They're already posted for you guys. This will be due Sunday night at 11:59 p.m. Don't wait till last minute, because if you guys have questions, then you won't be able to ask them of me come Sunday night at 11 o'clock at night. I won't be answering questions that late. So make sure that you guys don't procrastinate on this. I want to make sure that you guys get it done and that you guys can get any questions that you have on it answered. If you guys do have questions, office hours will be available Monday through Friday from 11 a.m. to 1 p.m. Stop on by, say hi, get your questions answered, make sure that you're feeling good about this content. The hours, or the office hour directions, those will all be up on Schoology. It will be through an app, Google Meet. So if you don't have Google Meet on your phone, on your computer, I suggest that you get it. It'll be useful for you guys, and that way you can just communicate with me however you feel the need to, and I can help you out however I can. If you guys have any questions, please let me know. I do miss you guys a lot. I hope that you're all doing well, and I hope to hear from you soon. If you need anything, again, just reach out. I'm happy to help. Other than that, thank you guys. I'll talk to you soon. Take care.